Hello, everybody, and thank you for joining us today. My name is Armando Verdiel, Technical Development Supervisor with Lighting Design Lab. Very excited to bring this two-part series starting today on the commercial heat pump water heaters, the why and how. So why are we doing this? Why is it relevant and important? How is it going to help us in energy? So very exciting topics. Uh, I'm going to let our speakers take us through it. But just for now, if you've been here before, you know the drill, but everyone's going to be muted. At the bottom right-hand side of your GoToWebinar panel, you're going to have the chat feature. You can ask us questions, comments. Please engage with us if something's unclear. You want to have some of us elaborate on something. It's going to be great. There's going to be just some engagement as well, be it via the Slido app or just through comments and questions. So hey, participate with us. The more you put into it, the more you can get out of it. After the webinar, there's going to be about a 30-second survey about how the experience was, how we did. So please fill that out. Very painless, and it gives us a good amount of feedback to understand what we need to adjust and what's going well. And as always, a recording of this webinar, as well as the handout of the slides, are going to be available on the lightingdesignlab.com website on our education page. Now, without further ado, I'm going to bring out Sean Hoffman. He's going to be moderating our webinar today, and he'll be introducing our speaker as well. Thank you, everybody.
Hi, everyone. Thank you, Armando. My name is Sean Hoffman, and I'm a project associate at DNR. I'll be leading moderation for today's presentation. It's going to be about an hour long, so feel free to drop any questions you have in the questions tab, and I will present them to Colin when there's an appropriate break or a time for questions. And then we'll also be taking advantage of Slido, like Armando said. So if you have any issues with that, or you can't get the link, reach out in the chat feature and I will assist you to the best of my ability. Without further ado, Colin, take it away.
Thanks, Armando and Sean, and thanks everyone for joining us here today. My name is Colin Grist. I'm a professional engineer with Ecotope, specializing in mechanical and plumbing systems. You may have heard of Ecotope before. We're a rather small consulting firm that does mechanical, energy, and plumbing design here in the Seattle area. And we really prioritize working on sustainable buildings that are really pushing the boundaries of what we define as sustainability right now. I have been working on heat pump water heating systems for the past 8 years with Ecotope, and so we've learned a lot over those past 8 years, and I'm here today to share some of those lessons, but save some for the next session next week, but also talk about why we chose to look at heat pump water heaters 8 to 10 years ago at Ecotope, and why the market is now transitioning to these really high efficient, great technologies for domestic water heating in our buildings. We can also use heat pump water heaters for space conditioning and other loads in our commercial buildings, but today we are primarily focused on heat pump water heaters for domestic water heating that we use in buildings. So we have a Slido today. This is a really great online interactive tool. I can't engage with you all as well as I could when we were in person a few years ago, but we have this tool to use for you to ask questions and for us to get some information on who you are, where you typically work, what your area of expertise is. So if you would please take some time to pull out your smartphone, excuse me, or reach it on your computer. You can get access to it with this QR code up here on the screen or at slido.com. And there is a code you have to input if you go to slido.com, and that is YSCL. And so I'll give you a moment to get to our introductory survey, which is our first Slido today. And we're looking to understand who's with us today and where you are joining us from, as well as a few other things. So that QR code is up here in the left-hand corner of the screen, and there's also the information and the event code there as well. Slido doesn't save any personal information. There's no emails or spamming of your email account, so you don't have to worry about that. I've been using this for over a year now, and it's a really great tool to bring us into a more engaged virtual classroom. So please tell us about your job title and where your city of residence is. We got project manager from Seattle, architect from Nashville. Welcome from Nashville. It's great to have people outside of the Pacific Northwest joining us. Heat pump water heating systems make sense in all climates. Seattle is a relatively mild climate, but these technologies are applicable to cooler climates. We've even at Ecotope installed some of these in Alaska, where it is a bit chillier here on those cold, dark winter days. Energy engineer from the Northwest, excellent, great to have you. Energy or engineer from BC, welcome. Hope you all are doing great today. Thanks for joining us. And what are you hoping to gain today from taking this course? More info on heat pump water heaters. Yes, we will definitely be covering that. We're going to be focused a little bit more on the policy and code side of things today for heat pump water heating systems, but we do give some presentations on the technical aspects about heat pump water heating systems, how to implement in these systems in buildings, where they might differ from a traditional gas or electric resistant system. So there's lots of great information out there, and we do a few presentations, and some of which you can reach on Seattle City Light's website as they've been recorded, and the slides are readily available. Let's see what else we got here. More info on heat pump water heaters, factors as to why I want to pursue electric water heaters. Heat pump water heaters are powered by electricity, so they are essentially an electric water heater, but they're not an electric resistance water heater like we're typically familiar with. Basic info, lessons learned. We will definitely try to cover a few of these. Please join us for the session next week where we'll be covering more lessons learned. Learn about what works well to see the best electrification of buildings. Yeah, electrification of buildings is a hot topic right now. I strongly believe we need to be moving in that direction. Commercial heat pump water heating systems are one way to do that, and to do it really efficiently, make smart use out of that electrical energy we're going to be using. And knowledge of new heat pumps. Yes, we might be familiar with R410A heat pumps. Those have been around for a while in the VRF market, in the split system. But we're going to be introducing some of the newer technologies that use CO2 as the refrigerant, which has a really low GWP or global warming potential, and also are very advantageous for colder climates because they're really efficient, providing water heating in those cold ambient air conditions. So a lot of great questions today, or what you're hoping to gain from this course, and I think we should be covering it fairly well, some of which will be at a high level, but we have more info next week. And like I said, there's some great presentations on Seattle City Light's website that you can look back to previous presentations we've given on more of the technical aspects around heat pump water heating systems, installing them, designing them, and commissioning those systems. So our objectives for today are really to cover some policy sides. We're really answering the question of why heat pump water heaters are a great solution for our buildings. So we're going to talk about some global, federal, and state commitments, and those are driving some local codes and standards, both in Washington State, more local in Seattle, but also regional across the United States. We're also going to be talking about the advantages of commercial heat pump water heating systems. The main advantage is energy savings. Another advantage is it's part of the building electrification platform, where it's one tool to really get some great advantage there and reduce the energy usage in our built environment. And then the last thing we're going to talk about is some Seattle City Light incentives, and there are still incentives on the table for folks from Seattle who are implementing these systems. And that's great because they are currently code required for certain building types in Seattle, which is outstanding that there's still money on the table for us all to capture, even if it's a code required system. So we'll highlight some of those incentives towards the end of this presentation. We got 1 hour to cover this information, so there's a lot to cover, but the climate crisis is real, right? You all are joining here today. There's a shift away from sources that rely on, or systems that rely on fossil fuels, and gas is definitely contributing to the climate crisis. We want to move the market towards more sustainable and more resilient buildings. We're building the buildings for the next 100 years, hopefully longer than that. We don't want to use some outdated, dangerous technology like a gas water heater in our building when there's a much more efficient and cost-effective solution like a heat pump water heater. There's also the issue of gas infrastructure, and when we start putting gas appliances in, like a gas water heater, we are contributing to more gas piping in the streets, in our neighborhoods, and there's many studies out there that have documented how leaky those systems are, how costly they are to maintain. And so as a society, we are actively moving away from those outdated, inefficient systems that are also contributing to asthma in our children and various other health impacts. We can do a lot with commercial heat pump water heaters, and so that's what I'm focused on today, speaking to you about really why this is a great opportunity to switch from an outdated, inefficient gas water heater to a much more efficient, reliable, and forward-thinking heat pump water heating solution. And one thing to first note is where our CO2 emissions come from. There's a significant portion that comes from our built environment. We have about 28% coming from building operations. This is keeping the lights on, the HVAC system running, and heating domestic hot water. There's another 11% that comes from the building materials, the construction techniques, and processes. So in total, we're looking at about 40% of the annual CO2 emissions are from buildings. Luckily, we are all working in that built environment or that building environment, and so we can actively take some steps here to reduce the carbon emissions or the CO2 emissions from that building sector. Transportation, right? That's another big one, and we might be moving to electric vehicles to address a lot of that, or doing more ride share and public transportation options. Industry is another big one here, contributing, but today we're really focused on 40%, which is a big piece of the pie, and we can implement solutions to dramatically reduce the CO2 emissions associated with that 40%. And like I said, commercial heat pump water heating systems are definitely part of the solution. It's going to take more than just a commercial heat pump water heating system to reduce that 40% down to closer to zero, where it needs to be by 2050, or some of our goals for 2050. But heat pump water heaters are part of the solution. They're low carbon technology. They're powered by electricity. We can generate or create that electricity via clean source if we choose to and prioritize that. And they also set us up for time of use pricing in the future when we start to see the cost of electricity vary depending on when we're using it. We already have that in California, and that will likely come to most of the regions in the United States within the next few years. So they're low carbon technology. They're really efficient. They're much more efficient than gas or electric resistance, and we will cover why they're so much more efficient later today. But in general, they're about 3 times as efficient as those electric resistance or gas water heating systems. So they're a great opportunity for us to reduce the annual CO2 emissions in our buildings and the annual electrical demand for those buildings. And there are a few global, federal, and state commitments that are really driving these changes towards heat pump water heating systems. We're all familiar with the Paris Agreement, and that's to reach global peaking of greenhouse gas emissions as soon as possible and be climate neutral by mid-century. So we have a lot of work to do to get to that state. And heat pump water heaters are part of that solution, and there's other aspects that are contributing to that as well. RE100 is a group of 300 international companies agreeing to switch to 100% renewables. These are companies that are taking that first step, being more active in the front line to really reduce the energy use and the associated greenhouse gas emissions or carbon emissions in our building stock. And then the Climate Pledge, we might be familiar with too. This is a group of over 100, I think it's close to 120 companies plus that are pledging to be net zero carbon by 2040. A lot of room or a lot of work to get to that point, but it's great to see that initiative coming from both the kind of the high-end federal aspect of it, but also down on the company by company basis. There's some federal policies, and really these federal policies are targeted at reducing the carbon emissions of the building stock by 50% by 2035. And we'll show you some graphs today of where we are and where we need to get to. There's incentives for deep retrofits right now, which if you have an existing building that might be an energy hog, there's incentives on the table, money on the table for you to retrofit that building to more sustainable, energy efficient systems, which is great because we all need help getting to our goal of 50% reduction by 2035. The federal policies are also prioritizing low GWP refrigerants. And so I mentioned that CO2 was one of those low GWP refrigerants, which has a global warming potential of 1. And heat pump water heaters that use CO2 are really efficient and really effective at providing hot water. So this is aligning with that federal policy to really prioritize low global warming potential refrigerants that are much more environmentally friendly than our R134A or R410A refrigerants that we have common throughout our mechanical and plumbing systems. And then targeting zero net energy building standards. This is a big push, but this is why so many codes and policies are becoming more strict in a lot of our eyes, really prioritizing the reduction in energy efficiency in our built environment, because like I said, the federal government realizes that we're building these buildings for many, many years, and so we need to be more forward thinking about our building stock so that we don't actively have to be retrofitting continuously. We can make smarter decisions right off the bat and set us up for a better, greener future. And then there's also they're trying to accelerate the building code updates. There's a big training aspect to this. Education is huge, and they're also training builders, and inspectors. Because these are more strict building codes, some of us might not be familiar with this. There's already a lot of price competition, and it's a tough market out there right now. And so the federal government is realizing that and trying to help us all navigate through that, both with education, incentives, building code updates, and guidelines to help us create these much more efficient buildings that will be reliable and robust and resilient for our future and our future generations. And Washington policies are really targeting this kind of 4-step platform where we're shifting away from fossil fuels to heat pump water heaters. We're accelerating the path to zero energy buildings through incentives, through education, and then we're reforming our programs and standards so that the buildings we're building today will be set up for that future. And we also need to retrofit our existing building stock. And so we'll talk about some of the House bills that are targeting one or some of these areas to really reduce the amount of carbon emissions in our building stock and to create highly efficient buildings for our future. And so the plan is really focusing on high efficiency heat pumps for space and water heating. And so today I'm really talking to you about that second part of high efficiency heat pump water heating systems. And in our next section on how we talk about some of the technical details of how to maximize the efficiency of those water heating systems, so we get the greatest payback, the smallest, shortest return on investment, and really set us up well for a reliable or reliably operating system. And the state has emissions goals too for this reduction. We want to be net zero energy or net zero emissions by 2050. And so we want to be, or we're targeting 40% below that 1990 level by 2030, only 8 years away right now. So we got some room or a little bit of time to get there, but we're talking about buildings here, and buildings take time to be built. So we need to be actively working together right now. And then 70% by 2040 and 95% by 2050, with the rest coming from carbon emission, or sorry, trades and so forth. And so we have these global federal policies that are pushing some of our local policies and standards, but Washington has its own commitments. Washington, along with California, are really leading a lot of this energy efficiency push because they see the great importance it is and the value that it has. So we're going to talk about House Bill 1257, which is the Washington State Clean Buildings Act for existing buildings. This is looking at the existing buildings out there, which ones are big and use a lot of energy, and how we make those more efficient. And so this is providing early adopter incentives. That was in 2021. I think those are continuing, but I'm not certain on that. But really, we're looking at large buildings here over 50,000 square feet and looking at them and how to make them more efficient. One of my coworkers at Ecotope recently finished, or about a year ago, finished doing an energy audit for this House bill to really look at where the energy was being used in that building. And with simple control changes and adjustments, they were able to save about 25% of the annual energy use. So a quarter reduction in annual energy use for one building based only on control changes and control optimizations. If we start to open the hood and look under it, we might see a few issues, a few leaky pipes, a few control set points that could be changed, and that can be easily be implemented for a cost of, and also be very cost effective. Not necessarily system changes, but sometimes that's necessary. We can often save a lot of energy with control optimization, and that's one great outcome. One great outcome of this, but there are many other ones as well. And there are incentives available for large multifamily buildings right now. My understanding is multifamily is not required. So there are incentives out there if you have a multifamily building that's existing and might be an energy hog, to look at that and to reduce the energy use in that building and get some money to do so. And there's, $75 million in early action incentives available for qualified retrofit projects in 2021. So there's like I said earlier, there's money on the table to help us all get to this more efficient state. And we can see here that the 29 legislation is really looking at 100% clean electricity, clean buildings, eliminating high fluorocarbons, so bad refrigerants. We're looking at lower GWP refrigerants, clean transportation, looking at better public transportation systems, more electric vehicles, and really efficient appliances. So the next area we're going to talk about is some Washington codes and standards. The appliance standards, this is a quick, easy slide. There are the heat pump water heaters that we're going to be discussing later today and in next week's session are all meeting the minimum performance levels established with this appliance efficiency standards. That's great. So if you have a heat pump water heater, you don't have to worry about it. It will meet that efficiency standard. These devices are really efficient compared to electric resistance or gas water heating systems. Here's one of our heat pump water heating systems installed in downtown Seattle. This is for the Bayview Tower, which is an existing building that was retrofitted with the heat pump water heating system. And this is a CO2 heat pump water heating system that's all packaged together. And if anyone was at AHR a few weeks ago in the Las Vegas area, I wasn't able to attend, but one of my coworkers went, and they have this unit on display, or a system very similar to this on display. But we can see that these systems can be dropped in place in many locations. We can retrofit buildings even if there's not much room in the existing plumbing or mechanical room for this equipment. But just walking through this picture, we of course have a CO2 heat pump water heater right here. So really highly efficient heat pump water heater. And we have some pipes, a cool water and a hot water pipe going to this building, this mechanical penthouse where there's water storage tanks. And so this is feeding into the existing water heating system in the building. And so if this system is working well, and it has been, that this is providing all the domestic hot water heating to the building, and the existing system is there for backup in case this goes down for some reason. So there's been multiple demonstrations that Ecotop's done, that other engineering firms have done throughout the region, that have proven that these heat pump water heating systems can be successfully implemented in both retrofits and new construction. They are also one of the simplest ways to comply in Washington State with the energy code, because commercial heat pump water heating systems are awarded all the eligible points. And so that Washington State energy code, if you're not familiar with it, you have to get a certain amount of points or efficiency points to comply with the code. And the heat pump water heating system will get you all of the efficiency points you needed. So it's a really powerful tool to both save energy in our buildings, but also to comply with some of our local codes and standards. And so it's often that easiest compliance option for new construction. And Seattle Energy Code, like the Washington State Energy Code, has goals to eliminate carbon emissions and decrease the electrical usage in the building, especially the unnecessary electrical usage. And heat pump water heaters are great systems to do this. As our grid is very, very clean here in Seattle, most of our power comes from hydro on the Columbia River. So we have a low carbon grid. And so we can install electrical devices like heat pump water heaters that move heat from the ambient air into water at a really high efficiency. So we're prioritizing the efficient use of that electricity decreasing the unnecessary electrical usage, and also operate in a very low carbon emissions system like a heat pump water heater. The Seattle Commercial Energy Code is now requiring heat pump water heating systems for multifamily and hotel motel. That's R1 and R2 occupancies. This is a requirement as of this year, 2022. So we're 3 months in right now. But essentially, service hot water shall be provided by an air source heat pump water heating system, not fossil fuel or electric resistance. There's other exceptions in there for water source heat pump water heaters in certain building types and systems. But in general, we're talking about multifamily buildings and hotel motel here that it is now required to do. Now, it also makes sense in most, if not all, commercial building types: libraries, fire stations, office buildings, restaurants, commercial kitchens. We're still going to see a significant reduction in the annual energy usage when we implement a heat pump water heater. But multifamily and hotel motel, we take showers, and so there's typically a large hot water demand, and so there's a lot of savings there. And that's one reason that the Energy Code is currently prioritizing making sure that building stock is built with these high efficient heat pump water heating systems first, before it rolls on to all other commercial buildings in the near future. So that was a lot on codes and policies and standards. I am a mechanical engineer who loves to use his hands, and so I'm not the best at policies, codes, and standards. I love talking about the technical details of how you actually implement these systems into buildings. So I'm sure some of you might have some questions relating to some of these codes and policies, and you're free to put them in the Slido or drop them in the chat, and we can have Sean moderate some of those questions now or later on as they come up.
Yeah, so we just got a question. Can you talk about the timeline for future code updates statewide and in Seattle?
I cannot, but I wonder if Armando or someone from SCL could answer that question. They're probably better suited.
Sorry, on the one in on chat, timeline on future code updates.
Yeah.
Is that the one we're talking about, Colin? So in terms, at the very least in Seattle, the code updates go in 3-year cycles. However, there are certain delays, and for example, right now and at some point in 2021, I believe, I want to say in February or a little later in 2021, was when Seattle adopted the 2018 building energy code, and these codes go in 3-year cycles. So obviously right now there's a technical advisory group working on 2021 versions of the energy codes to be adopted in a couple of years in the near future. But very, very good question. And if you're following the trends, a good amount of new construction renovation, they're already calling for electric heat pump water heaters. So that trend's going to continue on different codes. But if you have any specific code questions, feel free to email us, designlab@seattle.gov. We would love to get into a deeper dive with you guys. Thank you.
Thank you for that question. Keep them coming.
It looks like we have one here on the Slido. Are there financial incentives for existing buildings? There were in 2021 through the House Bill 1257. And I believe there are some of those still on the table going forward, but I'm not 100% on that. But there are incentives out there typically for commercial heat pump water heating systems. If you're looking at an existing building that is doing a major retrofit and needs an energy code or new energy code forms, get get a permit for that. There is opportunity to get incentives through SCL, Seattle City Light, for some of those higher efficient heat pump water heating systems. And we'll show you that later today. So we're going to talk next about some of the advantages of commercial heat pump water heating systems. We're going to touch on why they're more efficient. We're going to touch on some of the financial aspects of it. How much do these cost compared to gas or electric resistance? And how much energy will I save in operational costs? And how we compare those to our current systems out there. So first, heat pump water heaters are really a climate-friendly technology. They're super energy efficient, and typically the refrigerants, which is the, if it leaks and it's R134A or 410A, that's problematic. But the good thing about heat pump water heaters is they're confined to a small case. We have our VRF systems, variable refrigerant flow systems, for big buildings that are doing space conditioning, where you have a bunch of heat pumps on the roof and refrigerant being piped throughout the building to a bunch of fan coils in the spaces or zones. So there's a lot of refrigerant in that type of design. Compare that to a heat pump water heating system, and you have a much smaller amount of refrigerant all packaged together. And that packaging took place at the factory, a much cleaner, much more stable environment for us to work in. Whereas in the building environment, some of that refrigeration piping might have been installed under poor weather conditions or under a strict timeline because the crane was only serving for some aspects of the day. So there's more room for error in those larger systems that are using those refrigerants that are fairly toxic. So heat pump water heaters are really advantageous in that regard because they are moving towards less toxic refrigerants with lower global warming potential, but are also, the refrigerant that they have in them is a fairly small volume compared to those larger systems. So there's a great advantage there. Another great advantage is the overall efficiency of the heat pump water heaters. Heat pumps are moving heat, not generating heat or making heat. It's much more efficient to move that heat than it is to make or generate that heat. This isn't a new technology, it's just newly implemented. So the vapor compression cycle, the heat pump cycle, has been around for ages, or many decades, I should say. As your refrigerator in your kitchen is a heat pump, it's taking heat from inside that insulated box, your refrigerator, and discharging that heat into the kitchen. That process actively cools your refrigerator and keeps your vegetables crisp and your beer cold. So this is not the heat pump cycle is not new to us. We were using it in cars for AC, and buildings for AC and space conditioning, in many other aspects of our life. It might be new in the fact that we haven't, or many of us haven't, heated water with a heat pump water heating system. But essentially, for air source heat pumps, we need a source of air. We're extracting heat from this air. It's going into a super cold refrigerant. So even when the air is 40 degrees outside, we can still extract that heat into this very cold refrigerant, which is cooler than that 40-degree temperature. That's happening in our evaporator. It's essentially a big heat exchanger, similar to our radiator in our car. Then we compress that refrigerant, and that boosts the pressure and temperature. So now we're at a very high pressure and temperature, which means that the temperature is above our water temperature that we want of 120. Typically it's, maybe 180 depending on the refrigerant used in the circuit, or even higher than that in the 200s. So now we can dump a bunch of that heat that we extracted from our source of air into hot water, and that happens in our condenser, which is a refrigerant to water heat exchanger. Once again, it's a heat exchanger, and we're just dissipating that heat into our domestic water. And then it's a cycle. So we need an expansion valve to get back to the first state of that cycle. This is allowing the refrigerant to expand where we contracted or pressurized the refrigerant up at the compressor. This is also modulating the pressures across it so that we're always targeting a certain discharge water temperature here. And so this process is really efficient. It's typically about 300% efficient, a COP coefficient of performance of 3 or 300% efficient, which is 3 times as efficient as a optimized electric resistance water heater and over 3 times efficient of a gas water heater, as those are typically operating closer to around 85% efficiency, where this is 300%. So it's a much more efficient technology than a gas or electric resistance water heater. This technology has been around for decades and is fairly common in a lot of European and Asian markets for domestic water heating. But unfortunately, the US has been a little bit behind on the water heating aspect. And so we are just starting to implement this technology in our built environment, but it is a worthwhile technology to utilize for our future. And I talked a little bit about refrigerants earlier, but we can look at some refrigerants down here. We have R744, which is CO2. We have R410A, R134A, both fairly toxic, high GWP refrigerants. And then we have R290 propane, which is fairly limited in application right now. And those CO2 refrigerants are a really low global warming potential. This is what the scale is based on. And we have Sanco 2 and Mitsubishi with packaged heat pump water heating products specifically targeted towards multifamily building types, as well as other commercial occupancies that are common throughout our built environment. We also have some US manufacturers that have been providing heat pumps that use R410A or R134A. Colmac is up here in the Northwest. Nile is on the other side of the US in the Northeast. And then we have A.O. Smith and Rheem, a few of the bigger players in the water heating world. All of these companies have heat pump water heaters that are really efficient, often operating at that coefficient of about 3.0 or 300% efficient, and great options for water heating. However, one huge advantage of CO2 is it can work at rather cool ambient air temperatures, so in our cold climates, and it also has this low GWP. So I think I've started to see a lot of this market moving towards these CO2-based systems, or an alternative, which is held up by a bunch of red tape right now, is R290, and that's propane. Unfortunately, we're limited with the propane we can use in a heat pump, even though it's only a few pounds of propane in general compared to that 20-pound tank sitting out next to our barbecue. There's some danger and risk associated with that propane as it is flammable, and there's some red tape holding that up. But I see propane as a promising refrigerant, natural refrigerant that would be a great use for that fuel source. And we're not burning that propane in this case. We're just using it for the heat pump cycle. It would be the refrigerant. So a great opportunity there. And heat pump water heaters are much more efficient than central gas or electric resistance water heating systems. I have two pie charts up here on the screen. The upper left-hand one is a baseline multifamily building for the Pacific Northwest. So this shows where all the energy goes over 1 year into our building. There's about 25% that goes into water heating. Those are those two pieces of the pie up there. There's another 25% that goes into apartment plugs and lights, charging our cell phones, powering our TVs, keeping our lights on. There's 12 to 15%, depending on your climate, that goes into apartment HVAC. There's another aspect, or 25% quarter, that goes into some common plugs and lights, garage fans, other big electrical appliances in our buildings, in our commercial buildings. And then there is some that goes to common HVAC, keeping our corridors ventilated, keeping the leasing offices ventilated, heated and cooled, and doing some of those other common HVAC tasks. But we can see that the domestic water heating piece of this pie is about 25%. And if we apply a heat pump water heater to that, we can cut that by 2/3, save about 17% of the annual building energy use. So 17% of the energy over the course of a year would be saved by simply implementing a heat pump water heater instead of a gas or electric resistance water heater. And so we can see that these two pieces of the pie, the domestic hot water primary heating load, is reduced from about 15% to 5%. So cutting that by a factor of 3. And then domestic hot water temperature maintenance. This is our hot water circulation system, or the system that's keeping the water at temperature in the large distribution network of hot water piping. Our commercial multifamily buildings are a little bit different than single family homes, where we typically don't have that temperature maintenance system in the single family home application. We often don't have a circulation pump unless it's a rather large home or with bathroom groups on opposite sides of that home. In a commercial multifamily building, this is a big aspect of the system, and we can see that it's a lot of energy that we're throwing out by essentially cycling that water through the piping to keep it at temperature. That contributes a lot of, or that consumes a lot of energy on an annual basis. But luckily with the heat pump water heater, if we apply it correctly, we both address that primary heating load and the temperature maintenance heating load, and are able to save that 17% of the annual energy. So a great reason, and once again, this is one system, typically your water heating system, that's in a basement or rooftop mechanical space, whereas some of our other systems, like our plugs and lights, are distributed all across the building. So it's a great opportunity here for us to focus in and really address that system efficiently, while also addressing other energy usages in the building as well. And we've demonstrated performance of these systems both at Ecotope and at other engineering firms over the past 10 years or more. This is Sunset Electric apartment building. It's in the Capitol Hill neighborhood of Seattle, right across kitty corner from Cal Anderson Park. And this is a new construction building, but they did maintain the old facade on the ground floor. This building, I think, was constructed around 2012 or 2013. So it's been operating for about 10 years now, or close to that. It's a 67,000 square foot apartment building. There's 92 residential apartments, some 1-bed, some 2-bed, and a few studio apartments. And this building is using R134A Colmac air source heat pump water heaters in the parking garage. and those have been operating well. We've definitely learned a few lessons, as this was one of our early implementations of that Colmac R134A heat pump technology, but it has been operating at a relatively high coefficient of performance and really reducing the annual energy usage in this building. So we can see our 2030 baseline challenge. This is our baseline. This is our multifamily building, the pretty standard multifamily building that we've been building for the past years. And this has a EUI, or energy use intensity. That's how much energy use is going into this building over the course of the year, divided by the square footage of that building. So to normalize for the building area. And so we see a EUI of about 63 was our baseline, and our actual building is performing closer to 22.7. So a huge reduction in the energy use associated with that building. And this top yellow bar is our domestic water heating bar. So we can see that that was a significant portion of it. The Seattle baseline is a little bit less, just because we have higher efficiency standards than the Washington State baseline there. But we were able to dramatically reduce that energy use. And like I said, this building has been operating for close to 10 years with that R134A Colmac heat pump water heating system in the parking garage. And we put it in the parking garage because the R134A refrigerant doesn't perform well under about 40 degrees Fahrenheit. And in Seattle, it gets cooler than 40 degrees. But if you put it in a enclosed underground parking garage, we're creating a buffer zone for that air. And so that air, even when it's drawn into that garage at about 23 degrees on a cold day in Seattle, by the time it gets down to the basement level of the parking garage, the air is warm enough for those heat pump water heaters to extract the heat out of it. It's above that 40-degree threshold. We're getting a lot of great geothermal ground contact with those concrete walls that are uninsulated. There's a lot of thermal mass down there. So it's a really simple but effective way to utilize a technology that's limited by the air temperature in an area which has a few extreme days of low temperatures. And here's another project. This is a retrofit project that was done around 2015, 2016. Elizabeth James House. This was an existing building. It's serving senior low-income tenants. There's our 61 bedroom apartments. And we reutilized the existing system and essentially put 4 Sandin CO2 heat pump water heaters as the preheat before the existing electric resistance water heating system. And we dramatically reduced the energy use over a given year and are saving the tenants about $6,000 per year in their energy bills, which is fairly significant. So cutting that energy usage down by a factor of 3. And the CO2 heat pump water heaters are very low on that greenhouse gas emission scale. So that's another huge advantage to use that technology here. The CO2 is not limited to 40-degree ambient air temperature. So we actually located these heat pump water heaters right outside above here and piped them into the mechanical room on this basement level. And then a more recent project, this is another low-income housing unit serving homeless population, veterans, and low-income families. And here we have 65 apartments, both studio, 1 bedroom and 2 bedrooms, so a mix there. And we decided to utilize Samco 2 heat pump water heaters on the roof. But instead of doing one large heat pump water heating system in the center and distributing the piping out from there. We decided to do multiple distributed heat pump water heating systems. So if you're looking at this picture of the building, we're dividing vertically the units. So we have one system that's serving a bank of 3 apartments vertically, and then another system right next to it that's serving another bank of apartments. And this allowed us to use these smaller, more residentially sized products, the CO2 heat pump water heaters, as they have a smaller heat capacity than a lot of our commercial heat pump water heaters, and really result in a low first cost heat pump water heating system. We also were able to reduce the amount of hot water piping by distributing the heat plant systems across the building in a zonal fashion. And so that had a huge advantage on first cost of piping, as copper pipe, stainless steel pipe is really expensive right now, but also reduced the distribution loads associated with that temperature maintenance system or the hot water circulation system. So there are a few things that really worked out well there and made sense. It does mean that there's a few more maintenance points for those maintenance personnel, but typically with split system heat pumps for space conditioning, they're familiar with the maintenance procedures that a heat pump water heater needs as well, cleaning an air filter and making sure it's operating efficiently and effectively and not clogged up. So we can see our hot water usage over here. The typical mid-rise is coming in at about an EUI of 10 for that task, that load. We reduced this to 3.5. There are also other measures. We implemented split system heat pumps here for space conditioning, space heating, and we're able to reduce that from 10 to 6. And then other electrical measures on garage fan control, lighting optimization, ventilation, and other aspects of the building. We're able to reduce that load from the baseline of 20 to about 10, so cutting that in half. All in all, this ended up being a really efficient building, and it's been in operation for a few months now, so I'm really looking forward to watching this in the future and seeing how these systems are working in a few years. And so we talked about a few successful installations of these commercial heat pump water heating systems. We have more, but those are 3 we picked out to drive home the point that these are great options for new construction, large commercial buildings, great options for retrofit projects, as well as good options for new construction buildings with maybe a different design approach than one single central system. Maybe we want to consider multiple central systems to reduce the cost, the installation costs. But we also should consider the operational costs and the installation costs of some of these systems. So on the left-hand side of the screen, we have our operational cost comparison, and we have our commercial heat pump water heating system in gray and our more typical electric resistance water heating system in blue. So we can dramatically reduce the operational costs here. Is coming in about 40% of that, that electric resistance baseline assumption. For gas, right now, gas is about, or has historically been about 1/3 the cost of electricity. And heat pumps are about 3 times as efficient. So when comparing this to gas, it comes out very even right now. In the future, and since I did that analysis about 2 years ago, gas prices have skyrocketed or increased substantially. And so that equation has flipped on its head, and now heat pumps are a lower operational cost in a given year than they were previously, about coming in right around the same, in that same ballpark as gas. And gas is only predicted to get more expensive as the years go on. So it's intelligent. We're we're thinking ahead when we start to move from those systems or from that extraction fossil fuel source to much more efficient heat pump water heaters that are also using electricity to move that heat into water instead of a flame to burn and heat water that way.
Hey, Colin, we're just about out of time, but we had a question about if there's somewhere we can get more info about these case studies published, especially for like the total cost and savings.
Look, sorry, I'm running out over time, but if you look at Ecotope's website, ecotope.com, we have all these publications in our literature section on our website, and you can get a few more if you Google it too. Sorry, I was not aware that we were running out of time, but thanks everyone for joining me. We just had a few more slides left today, so you're not missing too much information, and we'll try to cover this some of this information during the next session next week. And here's a great graphic on installation costs comparing our gas water heating systems to heat pump water heating systems. We can see that, you know, we're about the same. Central heat pump is coming in, the average is a little bit more than central gas. But if we start looking at multiple central heat pump water heating systems over here, like we did in the HopeWorks, we're actually right on par with that gas as far as installation costs. So great opportunity. Individual heat pumps, one heat pump per unit typically ends up being more expensive than our gas water heating systems, but it's still less expensive than doing individual gas water heating units in that example. But yeah, thanks everyone for joining us. The last slides that we'll cover in the next session next week are a little bit on time of use pricing and grid flexibility. Heat pump water heating systems are really set up to take advantage of time of use pricing on the grid so that we're not operating the system when it's peak time of use pricing. We're operating the system only when electricity is inexpensive on our grid. And they are really set up and designed to do that. So another forward-thinking aspect of those commercial heat pump water heating systems.
Thank you, Colin. I dropped the Ecotope website in the chat for anyone who's interested to access those case studies.
Great, thank you. And I will go to the ending survey here, but we got, you know, it's good to understand how these systems are delivered. We have the custom engineered. This is having someone like myself involved. Specified built up. This is the IKEA approach. You're doing some of it yourself, but really looking towards that distributor to make sure you have all the pieces and the right tools to get those pieces installed. And then we have the plug and play system where it's just dropped off at your project site to provide hot water to the building. All great options, and some allow you more design flexibility than others, but they're all very reliable systems for commercial heat pump water heating. And then EcoSizer, it's a great tool to help you size your heat pump water heating system. You might size it a little bit differently than you did with a gas system, and this is a tool that's free on our website. It's in the chat that you can use to size. And here's our Seattle City Light incentives. You can see that there's definitely some money still on the table. So navigate to Seattle City Light's website if you want to learn more, or give your local utility a call if you're outside of Seattle's region. And thanks everyone for joining us today. And thanks for Seattle City Light and the Lighting Design Lab for hosting our session.
Thank you, Colin. We hope to see you everyone back for part 2 on the 9th. Have a great rest of the day, everyone.
everybody. Thank you all.